Kelly is an engineer for a company that drills wells for villages in Africa. The cost of drilling a new well is determined from how deep they need to drill to find water, plus the fixed cost of the pump. Kelly has collected data on 12 different well projects. So that's data's right here. So here's the X represents the depth, so how deep in feet they had to dig, and the Y represents the cost of the well. We've got the least squared regression right here. We can also rewrite that as Y equals 14.65x plus 1395. All right, so discuss the association between the depth of the well and its cost. So the form is either linear or nonlinear. Here we can see it's making a line, so it's linear. The direction is positive because it's going up. As we dig deeper, the cost gets higher. The strength, strong, moderate, or weak. I would say that this is moderately strong, kind of in the middle of moderate and strong. Are there any outliers? So probably not, because if this line continued, this point wouldn't really be considered an outlier. It's not far enough away. So no outliers. What does the slope of the least squared regression line represent? So the slope is the change in y over the change in x. So it represents the cost over the depth. So this number, 14.65, means for every 1 feet that they dig more, it costs 14.65 more dollars. For every 1 more foot they dig, it costs 14.65 more dollars. What does the Y-intercept represent? So the Y-intercept, so 1395, is the cost if they dig 0 feet. So this would represent the fixed cost of the pump. Because it said at the beginning that excuse me. It said that the cost is determined from how deep they drill plus the fixed cost of the pump. Okay, the 80-foot well that Kelly measured has a residual of $363. What was the actual cost of the well? So there are a couple ways we could figure this out. Remember that the equation for the residual is the actual data minus the predicted amount. And the predicted is what we predict from the equation. So if we know that the residual is $363, the 80-foot well that Kelly measured, so we want to find out the actual cost. And so then we need to figure out what's the predicted cost. Well, if it was an 80-foot well, we can find the predicted cost by plugging it into our equation. So y equals 14.65 times 80, because we want to dig 80 feet, plus 1395. So that is 14.65 times 80. 1,172 plus 1395. It equals 2,567. So the predicted cost was $2,567. So then we just solve this equation to find the actual cost. So the actual cost was $363 plus $2,567. So the well actually cost $2,930 to drill. Even though they had predicted that it would only cost $2,500, it actually cost $2,900. Complete the square to convert this equation into vertex form. So we've got a square here. We've got an x squared, and we've got negative 4 x's. So I'm going to have 2 on each side. So remember, these are negative, so it's going to be x minus 2 times x minus 2. And then for ones, we're going to need 4 ones. But we have 10 ones. We only need 4. So we're going to subtract 4 from both sides. So we get y minus 4 equals x squared minus 4x. Oh, sorry. We need 4, so we have to subtract 6. Y equals, oh my gosh. Okay. Y minus 6 equals x squared minus 4x. 10 minus 6 is plus 4. X squared minus 4x plus 4. That's this. X squared minus 4x's plus 4 ones. So that's right. Now we can rewrite this as x minus 2 times x minus 2. So that's x minus 2 squared. Then we just add 6 back to both sides, and we get y equals x minus 2 squared plus 6. So now our equation is in vertex form. Match each equation with its corresponding graph. So we've got x minus 1, the absolute value of x minus 1, the absolute value of x plus 3, and the absolute value of x minus 1 plus 3. So I know that this one is going to shift up 3. So that one's this right here. This is B. I know that this one is going to shift right 1. So that's this one, A. And then this one shifts up 3 and to the right 1. So that's number 2. Explain how you know which graph matched equation B. So I know that it matched equation B because, so number 1, because it had a vertical shift of 3 and no horizontal shift. Factor the quadratic equations below. So I'm going to make a box and a diamond. I'm going to get x squared minus 81, so that'd be negative 81x squared. We've got no x's here, so that's 0. So if I know two numbers are going to add to 0, one has to be positive, one has to be negative, and they have to be the same thing. So it's going to be negative 9x and 9x to make negative 81. Then I find my outsides. X times x is x squared plus 9 minus 9. So this equals x plus 9 times x minus 9. For this one, I have no common factors. So I'll make a box and a diamond. X squared, 36. 36x squared They need to add to 12x. So two numbers that multiply to 36 and add to 12. 6 and 6. The 6x and 6x. So the outsides of the box are going to be x times x, and that'll be plus 6 plus 6. So that's x plus 6 squared. Here again, no common factors. So I'll make my box and my diamond. I've got 4x squared and negative 3. So this would be negative 12x squared. And then we need them to add to negative 4x. So numbers that multiply to 12 are 2 and 6. They will add to 4. See, we need the 6 to be negative because the negative 4. Oh, this is negative 6 and that's 2x. So I think here I'm going to have a 2x, and then here I'll also have 2x. 2x times 2x is 4x. 2x times 1 is 2x. And negative 3 to get negative 6. So that gives us x minus 2x minus 3 and 2x plus 1. And then this last one, I've got 16x squared minus 25. 16 times 25 is probably a very large number. 400. So this is 400x squared negative. We've got no x's, so this is going to be 0x. So I know two numbers are going to be positive and negative. I think it's going to be 20. Because negative 20 times positive 20 is 400. So 16, I'm going to have 4x and 4x. 4 times 20 is 4 times 5 is 20x, and then minus 5. Oh gosh, not x. So this gives me 4x minus 5 times 4x plus 5.